Rhoden for ENGT259. This is my student project for the quarter, a machining no-go arm base. So just the bottom part. So what is a no-go arm? A no-go arm, machinists use it. We use it a lot for inspections because you can kind of use it to reference the size of something. So if you have like a 3-inch tall object and you're trying to mill something that's also 3 inches tall, you can reference off the 3-inch tall object with the arm and then actually check your part and see the deviation of that. And you can also use it for setups if you're trying to kind of go from you use a fixture and you're trying to locate off of a hole in a fixture, so you can use it for that as well. They're magnetic, so it just makes them really handy to kind of shove it on a spindle or something and go from there. My purpose was to recreate the base of one and kind of better understand the construction of it and the engineering that goes into it and everything. The parts included here, you can always see there's the base, there's the faceplate that goes onto the base, there's the dial and the stud. The stud is what attaches the rest of the arm that I did not get to modeling onto the body. So the sketch here on the left, you can see a kind of rough diagram that I found on Noga's website, and I kind of extrapolated some of the dimensions and the features out from that, and then I also kind of did some reverse engineering from just personally seeing them around work and using them a couple times. So here we can see the base. You can obviously see the tapped hole, the hole where the dial goes into. Unfortunately, I was not able to find any documentation on the actual internals of the Noga base because they are magnetic, and I was not able to find anything that actually showed how that worked or what that looked like. And I was not really able to take one apart and find any of how that stuff works just because I don't personally own one, and I'm not going to take any of the ones who work apart. So I just kind of had to imagine a little bit. So obviously here we can see the kind of internal hole there. We got all of our mass properties and everything, and on the left you can see where the sketches are and stuff. The faceplate, about the same. This one's made out of 1060 alloy and everything. I was trying to find out how I could actually get, if you go back here, you can see that it has the Noga name on the front, and it has the positive and negative kind of decals, but I was unable to try and get those on there. Here we can see the dial. I like doing the dial a lot. It might be one of my favorite parts of kind of this whole project, because finding a way to make that little dial handle actually seem relatively comfortable to use and relatively ergonomic and making it look nice was a really fun part of making the part and everything, which kind of goes to show that maybe in the future some surfacing learning is in order. And then here we have the stud, which is kind of the ball joint that the rest of the arm attaches to, that allows it a nice range of movement. And on the bottom there we can see the stud threads that actually thread into the top of the base. Here we can see the entire assembly kind of connected together, and you can get a bit of a better look where, you know, you can turn that dial and it would kind of magnet onto whatever metal surface you have and everything. And everything's got its own weight and mass and material, which we can obviously see on the right. Here in the drawings, I think all the drawings went quite well. Everything's defined. I was able to take the first drawing I did and just take that kind of, not size and shape, that layout, and just apply it to the rest of them so it was all very uniform, which I like to see, especially in the concept of actually manufacturing this, because then you can just send this as, you know, a package, and then there's no confusion with prints being very different from each other from the same company, which at work I've had to deal with and is always a very large pain. Here we can see the assembly drawing. I was going to do an exploded view, but it's pretty self-explanatory. And I just did some little general notes of, you know, make sure it's in the off position before you package it and stuff, so if you're not magneting anything on transport and all that stuff. And then bill of material and balloons are all applied. In conclusion, I definitely learned to better understand kind of the concept of doing assemblies especially with the previous SolidWorks class I took. 'Cause I took the engineering pathway SolidWorks class, so SolidWorks for engineers, which did not go nearly in depth with a lot of the concepts in this class, and I can imagine the class previously went into. So I had a little bit of trouble kind of getting into the pace of everything, but now I understand how SolidWorks works much better, especially with the assembly and design tools. And it was also good to kind of practice defining all the parts in an assembly, so actually making the prints for an assembly that you have and all the documentation that went into that. If I was going to continue working on this project, I would definitely try and model the ARM components. They were out of the scope of this project because they just were very complex with the kind of way that they clamp together and everything, because you have the kind of two arms that go around the ball joint, and then you have the screw that you use to kind of tighten them and stop them from moving, and then you can loosen it and move it all around. That just seemed a little bit out of the scope for this. I would also love to add a logo and label to the faceplate, but I just could not figure out a way to do it that wouldn't look terrible and I think kind of take away from the project. And I would also like to model the internal components better if I could. I wasn't able to find anything that really said what was inside of it. Obviously there's some kind of magnetic component attached to the dial that's going through the base of the body to allow it to be magnetized, but I could not find anything substantial enough to let me actually model those parts into an assembly. Overall class time I spent about 61 hours, and I spent about 14 hours on this project just kind of going back and forth trying to figure stuff out and then doing all the prints and everything. But yeah, thank you.